us understand torque now. Torque is analogous to force. Whatsoever is the rule of force in linear mechanics, translational mechanics, it is the kind of a role is being played by torque in rotational mechanics, as the analogous of mass is moment of inertia in rotational mechanics. Similarly, the analogous of force is torque in rotational mechanics. Force alone may not be able to produce a rotation. Like if this is a rod which is hinged like this, my fingers, they have hinged it, this is a nail which is passing through it, so I can rotate it like this. But if I pull it in this direction, I can maybe pulling it this in that direction, but there will not be any rotation. But if I apply a force in this direction, it rotates. Apply a force in this direction, it rotates. But if I apply a force along this line, it will not rotate. Even if there is a force, there may not be rotation. So force alone is not sufficient enough to rotate a body about an axis. Torque is always of a force about an axis. The unit of torque is Newton meter, and this is a vector quantity. Let's say if we have this rod which is hinged over here, nailed over here, and we apply a force of suppose 10 Newton and length of this rod is 5 meter. Then the torque of this force about this axis, then torque of 10 Newton force will be force 10 into 5, it is 50 Newton meter in the anti-clockwise direction. This force will try to move it anti-clockwise, and anti-clockwise direction is taken as positive in physics. Clockwise direction is taken as negative. So now what is torque? Torque is, number one, torque is always of a force about an axis. And this torque is, in simple terms, torque is force into perpendicular distance between line of force and axis of rotation. Torque is force into perpendicular distance between line of force and axis of rotation. If there is a body, you apply a force like this, this is called point of application of force. At this point the force is being applied. But if you draw this line, this is line of application of force. So torque is force into perpendicular distance between line of force and axis of rotation. Over here what we have done is 10 Newton is being applied over here, so this is line of force. So torque is force into perpendicular distance. This has been applied perpendicular to this distance. This is the distance. This is line of force, and the axis of rotation is like this. So this is the distance and this perpendicular distance only. So that's why directly I have done 10 into 5, that is 50 Newton meter in the anti-clockwise direction. One more thing to notice, that is Newton meter is also a unit of work which is scalar quantity. When we say work is equal to F dot S, we have done it in our earlier lectures. So unit of that, it was also Newton meter, which was joule. 1 Newton into 1 meter, that was joule. So just looking at the units, at times it may not be possible to predict the physical quantity these units stand for. So torque is force into perpendicular distance between line of force and axis of rotation, and torque is always of a force about an axis. Let's understand it further. Let's say this is a 10 meter rod fixed over here, nailed over here, so that this can rotate only in this direction. It can only rotate in this plane, it can rotate. Now over here a force of, let's say, 5 root 2 Newton is being applied at an angle of 45 degree. Obviously, when this force is being applied over here and this is hinged over here, when you apply a force like this, this will have tendency to rotate in this direction. So this will rotate in this direction, so anti-clockwise direction. We have to find what is this torque of this force about this axis. So we know that is torque is force into perpendicular distance between line of force and axis of rotation. So line of force is this, torque is force, what is force? 5 root 2 Newton into perpendicular distance between line of force and axis of rotation. This is a river, this is a man, as we did earlier. So the distance of this axis from this river, this man from this river, is this the distance. This is a perpendicular distance. If this line of force we are taking it as a river, and at the axis is a person is standing over here. So this person, how far the person is from this river, it is only this distance. It is not this distance. So at times the students, they can feel confused. They take this length. No, this is not the length. Line of force is this, distance is over here. So if this is 10, we know that this angle is 45 degrees. So this is also 45 degree. This is 90 degrees. So this is also 45 degree. So if this is 10, so this is 10 cos 45. So this is 10 cos 45. So it comes to the 5 root 2 into this is force into perpendicular distance between line of force and acceleration. This is 10 cos 45 is what? 1 by root 2. So that is equal to 15 Newton meter. The other way of doing it is, instead of making the components of this length, it may be at times wiser to break force into its components. Let's say if we take this example, what do we mean by this? So 5 root 2 Newton is this way. So it has two components. One is this way, the other is this way. So this way is 5 root 2 cos 45 and this is 5 root 2 sin 45. Torque of this force about this axis is 0 because force into perpendicular distance between line of force and acceleration. This is passing through acceleration only. So because of this force, this will not, if this is a rod which is hinged over here, you pull it this way, there will not be any rotation. So the rotation will be only because of this. So rotation because this is equal to 0. So the torque is primarily because of this force about this axis, and that is, now we have two forces. One is 5 root 2 sin 45 is once again 1 by root 2, and this is 5 root 2 cos 45 was once again 1 by root 2 Newton. So torque of this force about this axis is equal to 0 because this passing line is passing from the acceleration itself. So torque of this is equal to 1. So this is 5 into 10, angle is 90 degree, 5 into 10 is equal to 50 Newton meter, is you get the same answer. So many times it is wiser to break the force into its components and then you can proceed further. But if you wish to go like this, this is also okay, perfectly okay. There is nothing wrong with this. And torque is, if we say in vector notation, so torque is R cross F. This is the position vector and this is the force vector. Torque of force about this any axis is R cross F, where R stands for the position vector.